After World War II, the United States and the Soviet Union faced a mechanical bottleneck. Both superpowers possessed nuclear weapons, but delivering them meant loading them onto heavy bomber aircraft that took hours to reach their targets and could be shot down by anti-aircraft fire along the way. The Soviet Union had quickly matched American aviation capabilities with aircraft like the Tupolev Tu-95. This created a tense, careful standoff where early warning radars and fighter interceptors gave nations a window of time to react to an incoming strike. The military solution to this interception problem was the Intercontinental Ballistic Missile, or ICBM. An ICBM is a massive rocket that completely bypasses the atmosphere, flying in a high parabolic arc through space to drop a warhead on any city on Earth in a matter of minutes. The engineering foundation for these global weapons came straight from the ruins of Nazi Germany. Both American and Soviet militaries had scrambled to capture the V-2 rocket, the world's first long-range guided ballistic missile, along with the engineers who designed it. A functional ICBM erased the buffer of time entirely. It turned a strategic military conflict, relying on bomber fleets, into a hair-trigger standoff where total annihilation could arrive from space with almost zero warning. Developing a rocket capable of crossing the globe presented a unique problem. You had to test it. Firing a nuclear-capable missile thousands of miles toward your enemy's territory to prove it works is an easy way to accidentally trigger a full-scale war. The solution arrived via the International Geophysical Year, a global scientific initiative planned for 1957. It gave both nations the perfect political loophole to publicly announce they would launch small scientific satellites into Earth orbit. The pursuit of reaching space was driven by immediate national security. Sticking a metal sphere into orbit was a highly public, entirely legal way to demonstrate that you possessed a rocket powerful enough to drop a thermonuclear bomb on your rival. In the Soviet Union, the military assigned this task to chief designer Sergei Korolev. His top-secret directive was clear: build a functional ICBM capable of reaching the United States. Korolev's team designed the R-7 Semyorka. Because early Soviet thermonuclear warheads were incredibly heavy, the R-7 had to be massive, utilizing a unique design with 4 strap-on boosters clustered around a central core to generate the necessary lift. Korolev initially planned to launch a complex 3,000-pound scientific satellite known as Object D, but manufacturing delays with the scientific instruments threatened to push the launch into 1958, giving the Americans time to get to space first. To avoid losing the race, Korolev convinced the Soviet military to abandon the heavy science payload. Instead, they built Prostashi Sputnik, or Simple Satellite, a lightweight, polished metal sphere carrying nothing but a thermometer, batteries, and 2 radio transmitters. Those transmitters broadcast a continuous beep, beep, beep on standard shortwave frequencies. Anyone in the world with a ham radio could tune in and hear undeniable acoustic proof that a Soviet ICBM had worked perfectly. The Soviet space program sacrificed complex orbital research for a timeline dictated by the military. They realized that the psychological shock of being first was far more valuable than whatever data Object D would have collected. The United States actually had the hardware to beat them. Wernher von Braun, working for the U.S. Army, had already developed the Jupiter C, a highly capable rocket derived directly from military missiles. But President Dwight D. Eisenhower worried about international law. He feared that flying a military-derived rocket over Soviet territory at an altitude of 60 miles might be interpreted as an illegal overflight, or worse, an act of war. To avoid an international incident, Eisenhower explicitly ordered von Braun's military team to stand down. He assigned the satellite launch to Project Vanguard, a completely untried, civilian-only research rocket developed by the Naval Research Laboratory. Eisenhower's strict adherence to airspace legality and international optics tied the hands of his most experienced engineers. It allowed the highly secretive Soviet military apparatus to score a massive global propaganda victory. When Sputnik 1 launched in October 1957, it triggered an immediate panic in the West. The American public realized a rocket powerful enough to put a metal ball in orbit could drop a nuclear warhead on Washington. The CIA estimated the Soviet rocket weighed 500 metric tons, requiring 1,000 tons of thrust. In reality, the R-7 weighed just 267 tons. They completely missed that German engineers utilized rigorous weight-saving measures to achieve orbit. The crisis deepened 2 months later when the American civilian Vanguard rocket finally attempted its launch. It exploded just seconds after liftoff on national television, earning ruthless newspaper headlines like Kaputnik and Dudnik. The flawless Soviet launch, followed immediately by a highly visible American explosion, erased the global assumption that the United States held an insurmountable lead in science and engineering. In the wake of this public humiliation, the U.S. government quickly reversed course. They finally gave Wernher von Braun the green light to modify his military Redstone ballistic missile to carry a payload into space. On January 31, 1958, that military hardware successfully launched Explorer-1. It immediately provided massive scientific value by discovering the Van Allen radiation belts, zones of highly energetic charged particles trapped by Earth's magnetic field. By forcing the civilian Vanguard program first, and then allowing the military to follow the Soviet lead, Eisenhower achieved a paradoxical victory. The overlapping satellite launches established a new principle in international law, that national airspace sovereignty did not extend into outer space. What began as a terrifying race to build the ultimate weapon laid the legal and technological groundwork for the future. The very hardware designed to deliver global annihilation had inadvertently opened the cosmos for peaceful human exploration.